How's it going, everybody? This is Eddie, and welcome back to Learning to Program. We are on episode number 3 here, and we have covered printing to the screen and dealing with basic math in Lua. And we're ready to move on to words and then if statements, and if that doesn't take too long, we'll head on to while loops. We have here where we left off with. It is our main file that handles our basic numbers and adding and subtracting, dividing, multiplying. We're not going to need that anymore, so I'm just going to delete everything that we did with those numbers. Don't need it. I'm going to save. We can write similar stuff again if we need to, and we kind of will need to, but now we're going to deal with words. So if you remember, just going to write x equals 5. Remember, that was a variable with a number stored to it. Now, we want to write, I should mention, I said before in the last episode, I didn't know what words and that kind of a thing, words and characters and phrases and that kind of thing were called in Lua, and symbols, that kind of thing. When you string them together, they are called strings, which is what they're called in many other languages. I just wasn't sure if Lua used it, because I believe in some languages, I know this for a fact, in some languages, you separate integers, which are whole numbers, 1, 2, 3, and then fractions and stuff like that are separate, and you declare them and you create them in a separate way than integers, and so that like 1.5 would be written in code differently than 1, actually getting a variable of that kind, and since they're all the same in Lua, I believe they're actually just called numbers and not integers and doubles and floats, and that's what they're called in other languages. But strings are what it is in words. I believe that's the case. Alright, so x equals 5, that's how we did it with a number. S equals, quotes, just like inside the print statement, and we're going to say, this is a string. We could also say, dog, I should mention that, dog speak equals woof. Alright, so, if you take a look at how I wrote dog speak here, I had lowercase d, o-g, capital S, p-e-a-k. That is called camel caps. Let me write some more. I'm going to do it in like comments so we don't get an error. Some more camel caps. Start lowercase for variables. It's common practice. I don't know if it's required in Lua. In many languages it is, but it's good practice to do it. So this capital I for S is capital A, and capital E, example, capital O of capital C, camel, capital C, caps. It is when you write text all in one word write text with no spaces, and each new word is capitalized. Right? So there's no spaces here, because you can't have spaces in code, or the computer thinks you're trying to talk to two different things. In other words, you can't have dog speak, because it thinks dog and speak are two different things, because there's a space. But if you scan through this line here, it might be a little hard to read, but in general you could probably read it because the new words in this sentence here is marked by the fact that there is a capital letter in the first letter of every word, even though there's no spaces, and it's still readable. So it's called Campbell caps, and it's good practice. It's not required by the language. You won't get an error if you don't do it, but it is good to do it because it is helpful. So that's why dog speak is like that with the capital S, and wolf. Now you can have spaces in the string. How does it know that it's still part of the string? Because the string takes place in between the two quotes. If you look, when we printed hello in quotes, the quotes didn't print too. That is because the quotes are simply there to signify anything in between those is part of the string. Put whatever you want, and the characters that you put inside those quotes are going to be in that string. So now let's talk about this. I'm going to make a new one. It's going to be called not dog speak equals wolf. No quotes. Now, if you look, X does not have quotes around it. S does not have quotes around it. Dog speak does not have quotes around it, and not dog speak does not have quotes around it. Print does not have quotes around it. Print also has two parentheses on either side. When you do not put quotes around it, it is not a string. It is a reference to something, or it is a function name, or something like that, which functions we'll get into later. Print is a function. Okay, so the two parentheses at the end means a function. What is a function? Well, we'll talk about that later. Alright, so that does not work. Let's get rid of that. It's going to give us an error because, let me explain why. It's going to give us an error because it's going to say, okay, not dog speak is equal to wolf. Let me create a better example of this, actually. And I'm going to use numbers. X equal... No, I'm not going to use numbers, actually. So, we're going to say... okay, let's get rid of dog speak. X. S is equal to... This is a string, right? Okay, let me not get us right. S equals... This is a string. T is equal to... You don't have to use letters, of course, as you saw a minute ago. You could use entire phrases. But T is equal to hat. Okay? What the computer is going to do, what Lua is going to look for, is going to look for another thing called hat. It's going to look for something that is above this line, because it reads from top to bottom, and it's going to look for something that looks like this. Hat equals blah blah blah, right? It's not going to find it because this isn't here. Well, it is here, but let's get rid of it, pretend it's not. So if there is no hat equals, then hat has no value. Hat is a variable. Hat is a reference to a place in memory that is not there because it hasn't been created yet. So the program is going to crash. It's going to either not run the first time. It's going to throw an error like you saw before, or since I'm not seeing that little balloon right now, then it'll just give an error. Perhaps we can test it out. Well, I guess we actually have to print whatever T is. Nil. Okay, so it didn't actually give an error. That's very interesting. That's a interesting, nice little feature of Lua, I guess. You might actually want it to crash sometimes, because then you'd know that something was wrong, whereas you might actually overlook this problem if it didn't crash, if you had a bug in your code. But nil. Alright, it's a good thing to talk about. It printed nil. In some languages, this is referred to as null. N-U-L-L. It is the concept saying, basically, cannot be found, or empty. So, for instance, let's think of a good example here. If you, here's one. If you have I equals alright, what about well, forget it. Alright, so you get the point. So it means it's not there. So it's not equal to 0. It's not equal to anything other than not there. There is no value. There's nothing there. Just keep that in mind. And that's it for strings, really, except for one last thing, which is putting things. So you could also, so you could do this. Let me just write a few things. Make my keys on the correct. So print s, then t equals s. Print t and let's see, r equals elephant, and then s equals r dot dot tusk. That is what tusk, like elephant tusk. Let's try something else. Let's do trunk. Print. Oh, no. Print R. Okay. Run this. As always, print hello at the top. Next, we have x equals 5. Okay, but no print was called, so it didn't print anything down here to the console. S equals, this is a string. Print S. This is a string got printed, just as you would expect. T equals S. Print T. This is a string as it printed because T became S, and S was, this is a string. So when you print T, it's the same thing as printing S. R equals elephant. Couldn't think of anything for a while. R equals R dot dot trunk. Okay. This dot dot is called concatenation. It is when you take two strings, in this case, and it's generally strings, and you merge them together. You put one in front of the other. You add one to the end of the other one. There's a bit of a problem here, sort of, in my opinion. Well, then you print R. So we have R is equal to elephant, then R is equal to R, which is elephant, you know, what it already is, plus the trunk at the end. You can see there's no space in between the two, and that's because this string ends with no space, and this string starts with no space. So when you put them together, there's no space in between. So if we add a space at the end of elephant 1, and we save it, and we run it, now there's a space between elephant tusk. So just something to keep in mind that you need to add that space there. Alright, that's done. That's out of the way. Next, let's deal with some if statements. Okay, these are cool. So first, we can delete everything we have. Let's get a number here. It's gonna be x. We don't need that int. Sorry, x equals 5, like we had before. Okay, so now what if we want to do something if x, only if x is 5, and if x is not 5, then let's see here. Maybe we should do while loops first. No, let's do ifs. So if x is 5 to do something, and if x is not 5, then skip that bit. Basically what's going to happen. So we're just going to type if x equals 5, then then that's correct. Print x is 5. Okay. Now, this is an if statement. What an if statement is it only runs if the condition is true, if the argument is true. That's the word for it. So, in this case, the argument is x equals 5. Now, why is it equals, not just equals? I'll explain why right now. Actually, I don't even need to type anything else. You can see up here we have x equals 5. So that equals sign in code, it stands for, set, sort of, or assign. So this assigns 5 to the variable x. So that's what the equal sign does. But what if you want to check if the two are equivalent, if the two are equal to each other? You need a new operator for that, because the equal sign is already taken. So equals is used, two equal signs is used. So x equals 5 signifies, are they the same? And it's going to return true or false. Oh, I didn't cover that in data types. We're going to do that right now before I move on. Bool. This is another variable. You can name it whatever you want. Equals true. Potato equals false. Bob equals true. Now you can see that Eclipse is highlighting the true and false, because those are words that represent something called a Boolean, which are things that are true or false. So they can only be true or false. They can't be in between. Just a side note, when you're naming your variables, please don't name them Bob and Potato, or, well, I guess, name them whatever you want. You can name them Bob and Potato. It's a little bit hard to keep track of them when you name them really random things. Generally, I would rather have a really long name descriptive, an entire novel for a variable name that tells me information about what it is, even if I have to do something that's seemingly silly, like temporary integer count value equals 0, right? Even have to do something long like that, at least when I'm reading the code, I will be able to know what it is. If you just name it Bob, you're gonna get confused. I've had unfortunate people who I code with who, it's cute and it's clever and it works, but it gets confusing, especially to other people who read your code. But anyways, back to Booleans. So they are true and they are false. And they're either way. So this if statement here, the argument, the part in between the if and the then, it evaluates that and boils it down to a simple true or false. If it's true, then the code block that is on the next line, and for the sake of reading it, I like to indent it, will run. If the answer is false, it skips over. Actually, I forgot a part. You need the word end. In between the if statement and the then, if and then, really I guess it's in between the then and the end. So if the argument here, x equals 5, if that is true, then all of the code in between the then and the end will run. If it is false, it will not run. And for the sake of reading, I like to indent everything that's inside of it. So, let's save, and let's run this. Let's actually get rid of this hello. I'm getting a little annoyed by it. Alright, so it printed out down here, x is 5. What if we change x in the code here to be something else, anything else? I changed it to 8, you changed it to something else. Nothing ran, okay? So, theoretically, we could then have different things run for different states. I could put another if statement here. If x equals 8, then print x is 8. And now it will print out that. Okay, let's try something else. Let's put a less than sign. And then in the print statement, might as well put a less than sign. Now, if we set x to 2, to 2. If x is equal to 5, it'll print that, but it's not, so it shouldn't. If x is less than 8, it should print that it is. So it will print x is less than 8, right? Now let's set x equal to 5, okay? Now, if x is equal to 5, it'll print this, and it is, so it will print it, okay? Then, if x is less than 8, it'll print it. 5 is also less than 8, so it should print both. Yes, it does. Okay, now let's try something. So you can see where this is going, how this is building. You don't need to do this with numbers either. S equals high. If S equals high, then print. Oh. Good morning. And good morning is printed. Alright, so you don't have to do this with numbers, but numbers are easiest to work with, so you can see the power of this. Alright, let's get a little crazy now. Let's get rid of this if x equals 5 thing, and let's go into this if statement. Before we do that, we are before the end, okay, we're gonna put else, okay, and a new line and a new print, and we're gonna print x is not less than 8. Okay, so what does that mean? Actually, what we should do, greater than or equal to. That's what that means, greater than or equal to. So if x is less than 8, then print x is less than 8. Else print x is less than or equal to 8. Oh, sorry. Greater than or equal to 8. So with x of 5, it'll run x is less than 8. But as you can see, it didn't print what was in the else, because else will only run if the if statement arguments will false. So if we now go up to 100, which is way higher than 8, it now, instead of printing x is less than 8, it does print the x is greater than or equal to 8. Now to get crazy. Well, alright. Not that crazy, actually. We'll save that for one more. Sorry, I messed that up. Save that for one more thing. Next, let's put another else. But this one is going to be else if. And that is an else. Well, I'll explain it in a second. Else if x is greater than. Wait. We're going to do greater than or equal to 10. Okay? And then. And that actually should not be in parentheses. Then. Alright, and we're going to say print x is. Gotta do quotes. X is greater than or equal to 10. And else x is 9. Okay. Alright, let's explain. An else if statement will only run if the if statement above it is false. Right? Because if this is true, it's going to hit this, else do this, but it has a condition. So it's only going to run if the other one is false and if the argument it is given is true. So in this case, only if x is less than 8 and x is greater than or equal to 10. Wait. Sorry. Rather, only if x is not less than 8 and if x is greater than or equal to 10 will it print x is greater than or equal to 10. And then, of course, the else is if neither of those run, then it'll say x is equal to 9. So, x is equal to 100. It got an error. Right. No, there's an end. Oh, wait. Oh, okay, no space in between the two. Okay, so x is greater than or equal to 10. Next, let's go down to 1. X is less than 8. Let's hit 9. Prints out, x is 9. So this little block of code right here will detect if a number is equal to 9, or if it's equal to less than, or if it's equal to greater than. So it tells you not only if it is 9, but if it's not 9, is it higher or lower. Logic like this is crucial to writing all programs, basically. And the last thing that I want to do, which gets a little crazy, I'm going to write it in a new example, is I'm going to write s equal, I'm going to use words for this one so you guys, or strings I should start saying, so you guys can see this. My name is Eddie, so I'm going to use Eddie, s equals Eddie. If s equals Eddie, wait, if S equals Eddie, and I equals, let's see, let's pick an arbitrary number here, 55. So if x equals Eddie, then actually let's do this. If name equals Eddie and age equals 55, we'll say. So if there's no more x anymore actually, so I have to change that. So if name equals Eddie, then print. Let me make sure I got the spacing right here. Yeah. All right. Print. Hello, Eddie. Okay. And then end. Okay. And just for fun, let's put else. Print. You are not Eddie. Okay. Well, self-obsession time here. All right. Let's run that. It says hello, Eddie, because my name is Eddie. Let's spell it with a Y. And now let's try. You are not Eddie, it says, so you have to get it right, even though it's the same word. Okay. Now, inside that if statement, I'm going to put another. This is called nested if statements. Age is greater than 21, then print you can legally drink Eddie. Okay. And else print. You don't need an else actually, so let's just not put one. It's not needed. Right, so let's see. Age is 55. Name is Eddie. And forgot something there. Oh, I need to put end at the end of every if statement. When you see errors like this, that means your program crashed, it's not working, and you need to look. Yeah, so at line 15 it recommended, to close if at line 15. So, it's referring to this if. It also has Lua 21 here, probably because, no. Yeah, so look for something that has to do with the line number to help you out. But anyways, I fixed that. So, hello Eddie, you can legally drink. Now, what if we change our name down to 12? Hello Eddie, does not say I can legally drink. I don't think I spelled legally right either. Is there two L's? Yes, there is. Alright, I'm terrible at spelling. So that's if statements, okay? It's a bit of a crash course, really fast, covered a lot. They're important. You find you need them a lot. You need them a lot. Look up more documentation on them if you need help. Next episode, we will be going over while loops. Those are a little crazy. And then after that, we are going to write a few programs, complete programs, because that's all you need, really, including a tip calculator and a secret number game, a little word-based guessing game. But thank you for watching. I hope you found this useful. Keep leaving suggestions in the comments below if you want me to cover anything. And I will talk to you guys later.